Hello and welcome to McLean 360. So in this video, I want to solve a problem with you or some couple of problems to illustrate the concept of moment of a force. All right, so let's begin. So the question is saying that for the bracket shown in this figure, we are to determine the moment of the following. So first one is what? The moment of FA about C. So we want to find the moment of this force about point C here. And how can I do that? So we have to use what we call the principle of transmissibility. Transmissibility. All right. Now, if we are using the principle, then the principle states that the line of action of a force can always be transmitted along a straight line. Therefore, for this force, this is the line of action of this force. Therefore, if I want to find the moment of this force about point C, then I just need a perpendicular distance from this point to meet this point. In other words, what is the perpendicular distance which will meet this line? And technically speaking, this distance must be what? This distance must be the 250 force here. Is that right? And about point C, this moment tends to create a clockwise moment. So by the principle of transmissibility, I can even bring the force here. So I can even bring the force here as 10 kilonewtons. And we are saying that this force will cause some rotation in this sense. Is that right? And if that is the case, then the moment about point C is what? 10 multiplied by the moment arm, which is 250 millimeters. And that is what? 0.25 meters. Is that right? Therefore, the final answer is going to be 10 multiplied by 0.25. And that is 2.5. So 2.5 kilonewtons. Is that right? Or we can also, let me write it this way, 2,500 Newton meter. And this is actually clockwise. It's clockwise. And then we can also write this as 2.5 kilonewton meter. All right. Clockwise. So that is the first question for you. Let's look at the second problem. Now the second problem is saying that what? So this is A. B, how can I do B? The moment of FB about A. So we are going to use the same principle. This is FB. Is that right? This is FB. But you know, there is an angle here. Therefore, we need to resort to what we call the principle of moment. Principle of moment. And this principle is saying that if I have this force right here, then I can resolve the force and then find the moment of the individual component. So if I resolve this force, I'm going to get the x component as what? 15 cosine 45, which is 10.607, or let's say 10.61. So the x component of this force is 10.61. So 10.61 kilonewton. And the y component of this force is going to be, so the y component is going to be 15 sine 45. And that is going to be 10.61. So that is the y component, 10.61 kilonewtons. So if I want to find the moment about point A, what we will do is that, you know, this horizontal force, the line of action passes through the point. Do you see that? The line of action of the horizontal force passes through point A. Therefore, the moment about the horizontal force is what? Is zero. Moment of a force about the same point is zero. Do you get the concept? And we are actually tracing the line of action due to what? The principle of transmissibility. Is that right? Now we will look at the y component. You know, the y component will be perpendicular, and the distance will be the distance from here to here, which is what? The 250. In other words, 0.25 meters. Therefore, the moment about C is, of the moment of FB about A is going to be what? So it's going to be 10.61, and then I'll multiply this by 0.25. And then the answer is going to be what? So 10.61 multiplied by 0.25. That's going to be 2.65. 2.65 kilonewtons, or let's say 2000 Newton meter. And in fact, this moment is going to go in this sense. And that sense is counterclockwise or anticlockwise, which is the same as what? 2.65 kilonewton meter. And this is what? Counterclockwise. Is that right? We can also do clockwise as this, and we can also write counterclockwise as that. I hope it's clear. Let's look at point C. We have to find what? The moment of FB about point D. So it's the same FD, the same FB, this one, the same force, but this time around about point D. Okay, so where is point D? This is point D. Therefore, I would resolve it again. Now, if I resolve this force again, the S component is going to come here, which is the 10.61, and the Y component is this one. It's also the same 10.61 kilonewton. But this time around about point D, isn't it? So I would use the principle of transmissibility again. What is the line of action of this force? The horizontal component is this. Therefore, I need the perpendicular distance to meet this line, and that distance must be this distance here. Is that right? And that distance is what? 400 mm. In other words, 0.4 meters. Therefore, don't forget that the horizontal component will create a moment in this sense. Can you see that? Let's say if I bring the 10.61 here, by the principle of transmissibility, I can bring the force here. It's going to what? Cause a rotation in this sense. Do you get the point? Therefore, it's going to be clockwise. Okay, but then let's choose a convention. So we are going to some moment about point D. Counterclockwise should be positive. So with the first one, it's going to be clockwise. So let's negate it. So minus 10.61 multiplied by 0.4. Is that right? And then we will do the vertical component. Now the vertical component is this one. The vertical component is in this direction. Therefore, the line of action must be this. So we are using the principle of transmissibility. This is the line of action. Is that right? So I need a distance from the pivot or the point D to meet this perpendicular distance or this line of action, sorry. And then that distance must be what? The 250. Do you get the concept? But this force is going to cause a rotation. In fact, I can also bring the 250 here. Sorry, I can bring the 10.61 here. And about this point, it will what? Cause a moment which will go this way. Is that right? To go this way. And this way is what? Counterclockwise. So that one is going to be positive. So plus 10.61. But then this time around, I'll do what? 0.25. I hope the concept is clear. And what is it going to be? So minus 10.61 multiplied by 0.4 plus 10.61 multiplied by 0.25. And what is that? So I'm going to get minus 1.59. So minus 1.59, which is the same as what? 0.90 Newton meter. Now the negative sign is telling us that our resultant moment is actually clockwise. That is what it means. It means that the resultant moment is what? Clockwise. Or we can either do this. In terms of kilonewtons, is going to be 1.59 kilonewton meter. And then it's what? Clockwise, or I can do this the same. I hope it is clear. Let's look at the point D, the fourth question. FC about B. Is that right? Where is FC? FC is this force. This one. So this is FC. About what? Point B. So FC about what? Point B. Is that right? So how am I going to do that? Again, I'm going to use the principle of moment and then the principle of transmissibility. Is that right? Okay, so we are looking at the fourth point, which is FC about B. Is that right? So let's use the principle again. This time around, I will resolve FC into horizontal and vertical components. So the vertical component of FC is going to come down like this. Do you get the point? And the horizontal component is going to come this way. Now, the vertical component, or let's say the horizontal component is going to be what? 20 cosine 30. What is that? In fact, 20 cosine 30 is 17.32. So it means this is what? 17.32. Is that right? And then this one is going to be 20 sine 10. Okay. So this is 10 kilonewton, 17.32 kilonewton. Okay. Now what we will do is that we want to find the moment about point B. So we will use the principle of transmissibility again. Watch this. Please watch this. If I trace the line of action of the 10 kilonewton pulse, this one, it will pass through point B. Can you see that? Therefore, it doesn't contribute to any moment about point B. However, if I trace the line of action of the horizontal force, that is it. So I just need a perpendicular distance from this point to this point. And that is what? 400. So the actual moment is going to what? And you know, this is going to cause some anti-clockwise moment. Therefore, when we are looking at, summation of moment about point B, counterclockwise is positive, is going to be what? It's going to be 17.32 multiplied by 0.4. Now, what we are saying is that the vertical component does not contribute to any moment about point B. However, the horizontal component contributes to some moments. Is that right? And that is what we are saying. It is given by this. And this moment is what? Is going to be counterclockwise. Is that right? So what is it going to be? 17.32 multiplied by 0.4. So 6.928. In other words, 6928 kilonewton meter. Is that right? And then if I want to do, this is Newton meter. Newton meter, and then this is kilonewton meter. Counterclockwise, or I can also write counterclockwise. It's the same thing. Is that right? Now let's look at E. So FC about A. So E. Want to look at moment of FC about A. Counterclockwise is positive. So the same FC, but this time around about A. So I will not change the FC, but I will just change this one. Now I want to some moment about this point. Is that right? Please watch this. Please watch this. The horizontal component, if I use the principle of transmissibility, the horizontal component is having a line of action in this sense. Therefore, the moment arm must be the distance which will meet this line, and that is what? 0.4 meters or 400 mm. Therefore, and this was actually going to cause what? So I can bring, by the principle of transmissibility, I can bring the 17.32 here. And this will cause some movement in this direction, which is counterclockwise. Is that right? So that is what? 17.32 multiplied by what? 0.4. So 17.32 multiplied by 0.4. And then I'm going to do the vertical component, which is 10 kilonewtons. Now watch this, please watch this. You know, the 17 kilonewton, the 10 kilonewton is here. So the line of action must pass through this point like this. Do you see? That is the line of action of the 10 kilonewton port. Therefore, I just need the distance to meet this line, which is coming all the way here. And this distance is what? 0.25 or the 250 mm. So 10 and then 0.25. But the moment about this is going to cause some rotation in that sense. And that sense is what? Clockwise. So 10 times 0.25, and then I will negate it. Is that right? Because it's clockwise. Now, what is this? So it's going to be 17.32 times 0.4 minus 10 times 0.25. And this is going to be what? 4.428. 4.428. Or let's say 4428 Newton meter. And since it's positive, then it means it is actually counterclockwise, which is the same as 4.428 kilonewton meter counterclockwise. Is that right? Then finally, F. So what is F going to be? FD about A. So this is FD. This is FD. And FD is having a horizontal component of 25 kilonewtons about A. So this one is straightforward. We just need a perpendicular distance from here to meet the force. Is that right? And that distance is what? 0.4 meters or 400 mm. So for that one, it's going to be 25. But look at this. It's going to cause a movement in this sense. Is that right? And that moment is going to be what? Clockwise. Therefore, it's going to be, so 25 times 0.4. So minus 25 times 0.4. $25. So that is 10. So minus 10,000 Newton meter. In other words, the answer is actually 10,000 Newton meter and then clockwise or clockwise. And this in terms of kilonewton is going to be 10 kilonewton meter. The direction is what? Clockwise. I hope this is clear. All right. So that is the problem solved. Let's solve one more problem. Okay. So let's solve this problem. And that will be the end of the video. All right. So for this problem, I want us to find the moment of each of the forces. Is that right? About point A. I want us to find each of the moment of each of the force about point A. Is that right? So starting with the F1, so the moment of F1 about what? A. Is that right? So for F1, I'm going to get what? So I will resolve this into the horizontal and vertical component. That is the principle of moment. And then, so what is it? The x component is going to be 600 cosine 45, which is 424.264. 424.2, so 424.264. And then the the y component is going to be sine. It's the same thing. So 424.264. No, it's actually in pounds. Okay. So how do I find the moment? I will use the principle of transmissibility. I want to find the moment about point A. So I will try and trace the line of action of this force. Do you get it? It means that by the principle of transmissibility, I can even bring the force here. I can even bring the 424.264 here. Do you get it? Then I just have to multiply this by a perpendicular distance to meet this line. And that is what? The 3. Therefore, the moment about A, M1A, is going to be what? Is going to be, so with the horizontal direction, and don't forget that this moment is actually going to be in this direction for the horizontal force, which is what? Clockwise. Now let's say that we are summing moment and counterclockwise is positive. So for this one, it's going to be minus 424.264. Then multiplied by 3. After here, I would look at this one. Now with this one, if I trace the line of action of this force, it is going to be in this direction. So I just need a perpendicular distance to meet this line. Do you get the concept? And the distance from here to meet this line is the 6. But the moment is going to actually cause it to rotate in this sense. In this sense. And that sense is actually counterclockwise. So we're going to be plus 424.264. And this time around, I'm going to multiply this by what? 6. What's the answer? So I'm going to get 424.264 multiplied by 3 plus 424 multiplied by, 424.264, and I'm multiplying this by 6. There is negative here. So the answer is going to be 1272.792. 1272.792. And this is actually in pound force feet. And the answer that we have here as is positive. Is that right? Therefore, it's what? Counterclockwise. Is that right? Let's look at the second force. Let me write it here. We are looking at the second force. So F2. For F2, Is that right? So for F2, I'm going to get this. This is F2. So what I will do is that I will resolve again into Y and then X component. Now the X component is going to what? 750 cosine 60. And that is 375. Okay. And the Y component is going to be 750 sine 60. What is that? So I'm going to do 750 sine 60, and that is 649.519. So 649, let me write it here. 649.519. Okay, so that is it. It means that if I want to find a moment about, so for instance, the horizontal force, the line of action actually will pass through the point. Can you see that? Therefore, the moment of this 375 about the point A is 0. In other words, it doesn't create any moment at all. So that is 0. I hope that is clear. However, the vertical component is having a moment arm, which is the whole of this distance right here. And that will be 6 plus 3 plus 3. And what is that? 6 plus 3 plus 3 is 12. Therefore, the actual moment, in fact, this force is going to cause a movement in this direction. And so it's going to be counterclockwise, which is 649.519 multiplied by 12. And what is the distance? What is the magnitude? Or what do we get? It's going to be 649.519 multiplied by 12. 7794.228. 7794.228. And the value is in pound foot. This is actually counterclockwise, or you can do this. Finally, let's look at summation of moments for the third force about A. So we want to now look at the 900-pound force, this one. So again, we are going to resolve this into X and then Y. The X component is going to be 900 cosine 30. What is that? 900 cosine 30, which is 779.423. So 779.423. And then the Y component is going to be sine, which is 450. So it's going to be 450 pounds. And then it's going to come vertically downwards. If I want to take the moment about A with the horizontal force, the line of action is here. So it's going to be, the line of action is actually in this direction. Is that right? Therefore, the perpendicular distance to meet the line of action must be what? 3. Can you see that? So by the principle of transmissibility, I can even bring the force here. And then this moment is going to cause a moment which is what? Counterclockwise. Therefore, I'm going to get what? 779.423 into 3. And this is counterclockwise, so it's positive. And then I will look at the vertical force component, which is in this direction. Now, the line of action of that force is this. Therefore, I just need a distance which is perpendicular to meet it. And that distance is what? 6 plus 3, which is 9. So, but then the moment of the 450-pound force is going to be what? Clockwise, it's going to come in that sense. So minus 450 multiplied by what? 6 plus 3, which is 9. Is that right? So what is that going to be? So 779.423 multiplied by 3 minus 450 multiplied by 9. So the minus sign means it's actually clockwise. So minus 1711.731. Okay. So technically speaking, this is actually 1711.731 pound foot, and this is actually clockwise. So the resultant moment is going to be what? Let's look at the resultant. We're going to 1272.792 plus 7794.228 minus 1711.731. Now what is that going to be? So let's pick our calculators and punch it. So we are going to get what? 1272.792 plus 7794.228 minus 1711.731. And that is 7355.289. 7355.289. But this moment is going to be counterclockwise because it is actually positive. Okay, so that is our problems which have been solved. Thank you very much for watching.